Are you Democritus? Oh, thank goodness. Okay. Can I talk to you for a second, sir? Okay, there's no easy way to say this, but I'm Cheyenne Barnes. I'm from the future. I was sent from the American Chemical Society to tell you about all the things we've learned about atoms because of you. So, I have these pictures, well, you and all the scientists after you, to show you what they thought the atom was. So you know how you thought the atom was this circle sphere? Well, it's actually so much more. You purposed the existence of an atom. You started it all. You said that if you cut matter into smaller and smaller and smaller pieces, you'd eventually get an atom, uncuttable. You're the one who started all this, who actually got scientists into looking to see if it was actually true. Okay. So after you, there was a guy named John Dalton from 1803. Yes, 1803. He said that all matter was composed of atoms, that all atoms of the same element are identical, and atoms cannot be created or destroyed. He also said that chemical reactions occur when an atom is rearranged and compounds are formed by the combustion of two or more different atoms. Well, this is an example of him saying atoms or mass cannot be created or destroyed. So this is one oxygen atom, and this is two hydrogen atoms. And when you add them together, it equals a water molecule. But the mass consistently stays the same because when you add these two together, none is destroyed and none is created. So after John Dalton, there was a guy named J.J. Thomson in 1897. He discovered electrons, which are negatively charged particles. He came up with the plum pudding model, which is what this is. So there was these negatively charged particles. These are electrons, these little dots, and then all around it is positive space. That's why there's a big plus sign. So after J.J. Thomson was Ernest Rutherford in 1912. He discovered the nucleus, which is this. He did the gold foil experiment and found small, dense, positively charged particles in the center, which are protons, these pink things. And the electrons are all around the nucleus. After Ernest Rutherford was Niels Bohr in 1913. He discovered energy levels. So in Ernest Rutherford, he said that electrons are just in random spots around the nucleus. But Niels Bohr said that they were in energy levels. There are 2 in the first energy level, 8 in the second energy level, and can be up to 16 in the last energy level. But this is actually not true. But we still use it because it's much easier than how things actually are. It's just easier to see all the electrons because you actually can't see them. Niels Bohr said that they travel in definite paths around the nucleus. Even though that's not true, it's a good way to see them. So after Niels Bohr was James Chadwick in 1932. He came up with neutrons, which are in the nucleus with the protons. They even out the protons, because you can't have so many protons without any other thing to help them stop repelling each other. So the green is the protons, the black is the neutrons, and the orange around it, this little circle, is the neutrons. Outside are the energy levels, the pink, the electrons. After James Chadwick was Henning Brand, which was a German scientist who founded the first element, phosphorus, which he actually discovered it by doing stuff to urine. So this is how we would draw phosphorus, because we use Niels Bohr's model, and we put all of our protons would be 15, and all of our electrons are the same amount because it evens out the charge. And there are 16 neutrons. And this, we made a periodic table which has all the elements actually discovered. And this is element 15 because they are categorized by the number of protons, which is 15. Well, I have to get back to 2017. I really was nice talking to you. I'll see you later. Well, not really. I mean, I'll see a picture of you on the internet. You don't know what that is. Well, I gotta go.